હવે વાંચન શરૂ થઈ રહ્યું છે. સ્ટાર્ટિંગ નાઉ. શું એ ધીમું કરી એટલે બંધ થઈ જાય કદાચ. So we will start our today's session. We expect that by end of this session, we should be ready with our project. So next time, we expect that all of your subgroups, 5% in each group, should be ready with a project proposal. Even if full proposal is not there, we expect at least method of study, whether it's case control, course study, or the cross-section study, simple. And then you should be able to define all the variables, various types of variables in your study, at least characteristic variable whereby you are describing, and then continuous variable where you can find out the mean. These two things are required. So your the proposal will have a method, and method will have a format, and format will have around 8 to 10 variables in which you will actually collect the data, maybe around 20, 30, 40, or 50 people. You analyze in the AP Info software, and then you should be able to present within your groups. So on Wednesday, I expect that all of you have prepared a format and you have collected the data. And the analysis will also be there in subgroups. I have another mobile through which I'm connected to all the groups. So tomorrow onwards, at least you should be start putting your topic, then method, and then the few format, and start collecting the data. On Wednesday, we'll be looking at the data of all of you, and if there is any problem. I again repeat that I already shared the number of Hitesh Bhai with you, that if you have any problem in handling the AP Info, at least he will install and he will teach you the first command, read. That is his duty. If you can't do it, the rest of the thing, tables command, means command, you should be able to do it. So in your study, today we'll be talking in general, finishing touch about as far as the various types of studies concerned, but then the non-parametric test that we'll be taking on next Monday onwards. The last on next Monday exclusively will be on non-parametric test, which will be very useful when you have a very small sample size, and it will be useful for the clinician also. So let me start sharing with you. Statistics basically is the science of probability, and sometimes you need to calculate the probability. At that time, the probability slides will be very useful. Then I'll be talking about the case control study, then the cohort study, and then about the randomized control trial, if time permits today, or otherwise next Monday. The Wednesday will be exclusively for you to present your findings in the group. You will be doing the screen sharing, at least one screen share by all of you. And before we end today, 3-4 sampling technique we will be talking about, so that and also how to calculate sample size, that will be doing on AP Info, so that your study can include that. So let me start with the probability. Now, the probability, basically, what are the chances that the event will occur, or on an average, what usually happens. So when we talk about the p-value, right, we say that probability of occurrence of the chances, right, probability of the event occurring by chance. Or sometimes the word uses relative frequency. For example, if there are 100 delivery takes place in first delivery, that how many are boys and how many will be girls. So probability that we can find out. Or let's say, what is the probability that if you are giving some medicine, what will be the outcome? The patient will be cured, not cured, or will remain status quo, like that. So this probability, very simple. And the only thing that in terms of percentage, we talk about 100%, this is out of 1. And this is because when we want to apply to the standard normal distribution curve, usually it's like a unit 1 kg or 2 kg like that. If there's a, let's say, 1 lakh population or 50,000 population, we denote as 100%. Similarly, we call it as a 1 as far as the probability is concerned. And if there is event yes or no, then Q is equal to 1 minus P. So together it will be 1. This looks simple. So 50% plus 50%, suppose 100%, in probability we'll call it 0.5 plus 0.5. So simple calculation, number of events occurring divided by total number of trials, that will give you the probability. Suppose there are 200 patients and 80 patients are surviving. What are the chance of survival? 0.4. Then what are the chance of not survival or death? Is 0.6. So in terms of percent, 40% will survive and 60% will not survive. Now, looking very simple, but when there is a complex phenomenon, suppose one drug given, it will be effective like this, 2 drug, it will be like this. I will give a simple example of poliomyelitis. We are giving a oral polio vaccine, and sometimes 1 dose, 2 dose, 3 dose. Then here the law of probability is coming. If any viral vaccine, most of the time, particularly in the polio, when you give a vaccine, let's say oral polio, you are giving the first dose. I'm not talking about 0 dose, because 0 dose is less likely to be effective. But when you give a first dose, 50% of the children will develop immunity. So let's say we have a 200 children, or let's say keep it as 100. Out of 100 children, 50% will develop a immunity with a 1 dose. Now, when you give a second dose, again there's a 50% probability that the children will develop immunity. So if you give a 2 dose, first dose 50% covered, next dose out of 50-50, that is 25% covered. So when you give a third dose, remaining 25, 50%, that is 12.5 added. So 75 plus 12.5, 87.5% will be covered. So why we give a 3 dose of polio? Because when we give it orally, probability of that develop the immunity is like that. So in this case, what you are doing, that you are summing up the probability that how many children will develop the immunity. So for this, there are certain laws through which we calculate the probability. Now, when you calculate the probability, the word mutually exclusive is very important. This will happen or that will happen. For example, if you are giving an injection, patient will die or survive, that is a mutually exclusive. Or you are bringing the, for example, king or cross, is a mutually exclusive. Either it will be king or cross. It is not the both the things occurring together. That's why, right? So it gives like this. So similar, another example, birth of male child, that means it's not a birth of female child, like that. So in this case, mutually exclusive events are there. Then if let's say there are 10 events which are mutually exclusive, then probability of 1, probability 2, everything together will make 1. So suppose if you use the word probability of male child or probability of female child, then P for male, P for female together will make it 100%, like that. Then when you use the word and or use the word or, that is very, very important. Because when you want to say that you are using the two medicines together, right? So let's say one medicine will kill 90% of the bacteria, and another medicine, let's say it will kill 80% of the bacteria. Then what will be the effect if you give both medicine together, this and this? The number of bacteria killed will be different. If you give serially, it will be different. If you give it together, it will be different. Similarly, suppose there is an immunity of the people, innate people, and good immunity, and you give antibiotic. Immunity is not proper and you give immunity, there will be different kind of the outcome will be there. So in probability, what usually we say that if they are not associated and you are going to use the word and, then there is a multiplication of probability. But if you are using the word or, these or that, that means together. You say that whether it is a red or black, no problem. So even if the red is there, that probability plus it's a black, together it will be added. So there will be the total will be by summation. While in this multiplication, if you use an and, that means 1/2 multiplied by 1/2, it will be 1/4, because the probability of both working together is less. That's why we are doing multiplication. But when there is a relation with each other, at that time, we can't use the multiplication law. For example, out of 100%, 10 smokes heavily, and probability of getting cancer in heavy smoker is 1 into 100. So we say that 10 out of 100 multiplied by 1 out of 100, that we cannot do, because smoking directly affects, even though it's not moderately smoking or not heavily smoking, is a mild smoking, but because it is affecting and can lead to the cancer, we can't use like this, right? But if they are different, then you can use. So other thing is binomial law of probability. This is in binomial law of probability, there is a success or failure. So P plus Q is equal to 1. Now, this is a very interesting, when you want to say that how many will be 2 times P, 2 times Q, 4 times Q, something like that. At that time, there is a formula which we are using for binomial. Here, the classic example is given that 20% of children under 6 years of age were found to be severely malnourished, grade 3 and 4. And if only 4 children were selected at a random from the 4 project, what is the probability that 4, 3, 2, and 1 and none being severely malnourished? That means out of 4 children, 0, 4, 3, 2, 1, how many will be having a malnutrition? So that is a question. And this is impractically, it may be required when you are doing the community health project. So here the equation is P plus Q raised to n. Here we are having a 4 children. So we are taking P plus Q into 4. So the probability 20% means 0.2 for unit. And we have 4 children. So P plus Q raised to 4. So in this case, if you use the formula, then the result will be P raised to 4, that is 0.2 raised to 4. So 0.2 into 0.2 is 0.04, and 0.04 into 0.04, that will be 0.0016. Here, here they have not given correct. There's a slide, I need to correct this, but the answer will be 0.2 raised to 4. That is the correct answer. Similarly, when you are using the t-test or chi-square test or z-test, in that also we are doing nothing but calculating the probability. So before I end it up, if there's any question, we'll take a question. Just you should remember before there is any question, we'll take a question and then we'll start further. So when you are using a Z table, for example, if the X value, observed value, is X bar plus minus 2 standard deviation is away than that, away from the mean 2 standard deviation, then we say that the probability within this group is less than 0.05, less than 5%, because it's out of 95% zone. So that also is derived from this principle. So now, after 1 or 2 questions, we'll be talking about the case control study, cohort study, and then we'll be moving further for the type of project proposal which you're going to take, particularly in the sampling techniques. So, any question, probability? I will give one example for you to calculate. Suppose you have around 20%, out of 20%, 3% are having diabetes. Listen carefully. Let me write in the chat box so that you become active. Out of 20%, 3 are diabetic. And the question is that if you randomly pick up 2% from 20 individual, what is the likelihood that at least 1% will have a diabetes? At least 1% will have diabetes. What is the likelihood? Let us wait for answer. Not a single person answering means what is the problem? So my question is, what is the likelihood that at least 1% is having diabetes? So if you pick up the first person, the likelihood would be that the person is having diabetes is 3 out of 20, right? And the second person, what I say, or that means 3 upon 20 plus another person is also 3 upon 20. That means total likelihood is 6 upon 20. That is the likelihood that at least 1% will having a diabetes. So another question, that what is the likelihood that both person will have a diabetes? What is the likelihood of that both a person will have a diabetes? In that case, we are picking up 1 upon 3 by 20, 1 upon 3 by 20. So, this. Nine upon 400. That will be the likelihood that both the person having diabetes. It is 9 out of 400 trials. So at least you should have a calculator with you. I repeat the another example now. You have 20 malnourished children in 400 population of children, right? Now my question is, if you randomly pick up one child, what is the likelihood that that child is suffering from malnutrition? At least give answer. What is the likelihood? 1 upon 20. That is true. But now the question is, what is the likelihood if I take 3 children? I am taking 3 children. What is the likelihood that all the 3 children are having malnutrition? Give me that calculation. All the 3 children are having malnutrition. What is the likelihood? So anyone, sir? 1 upon 8. This is true. Wonderful. I hope this is answer because 1 into 20 into 1 into 20 into 1 into 20. But if I ask you a question, out of these 3 children, at least one child having a malnutrition. Out of 3 children, at least one child is having malnutrition. What is the probability? So this question I am going to take into the small groups. You should have that answer. Anyone? What is the likelihood that at least one child is having the malnutrition when you are taking 3 children? So answer simple, 120 plus 120 plus 1, so it is 320. So I hope that you understand about this probability. And in your small group exercise, you discuss, open up your Z tables, T table, and the chi-square table, and try to interpret. So on Wednesday, we are going to have an actual explained which is done by you and interpretation. So I'm now sharing another slide. So in as far as our studies are concerned, initially we should not start experimenting ourselves. For example, you are finding out a case, for example, COVID-19. So you cannot start trial on the human beings or directly various things. So first you should learn about observe the thing. And that's why we use the word observational study. And observational study, and then other thing, intervention, you do some kind of, then you go for the experimental study. In observational study, because most of you are the guys from the MD, PSM or community medicine, professor will not go into much detail, but in case control study, we should be very clear that outcome is already there. And outcome need not be a case. Outcome could be anything. So outcome is there of a particular thing, and outcome is not there in other thing. So it's not disease we are taking usually outcome. Let's say malaria is there, malaria is not there. But similarly, you can also find out that the cure is there, cure is not there. That we can also take as a case control study. So in case control study, basically, case means study for which the study of the event which you would like to consider, and absence of the event in another group. So these two things you are taking. But usually, let's very simple example, that a person having common cold and person not having common cold. In this case, you need to pick up person. Let's say if you take the same house and you are doing the study case control study, probably it will be a little bit difficult. So it is much better. Suppose you want to study 10 cases of the common cold, then you are supposed to take 10 cases of common cold, not having common cold. So having common cold, not having common cold. So this is, and you ask both the people that whether you are exposed to certain things or not. For example, your overcrowding was there or not, or the type of fuel which was used, or a habit of smoking, or let's say traveling in AC car, like this. So in both the group, we are asking that whether you were exposed or not. So we are starting with the outcome. So we say retrospective studies. And in control, remember that usually we should take such a control so that which you can compare to remove the biases or to remove the confounding factors, same age group, same social condition, etc., etc. And you want to have a kind of exposure. That exposure, for that you need not make a matching for that, right? So if you are doing that, the common cold is precipitated by air condition, right? Though you need not match the control person should also be exposed to the air condition. That we cannot take like that, because that's why we want to measure the exposure in both the groups. So you need to define case, but remember that case could be any kind of outcome. Then match. Then you try to find out by history how much exposed. Suppose they are staying in an air-conditioned car, how many hours they remain in the air condition, how frequently they remain, all these things you should be able to do it. And in analysis and interpretation, you'll match the exposure was there or not, and outcome was there or not. So in epidemiology, we say the distribution and determinants of disease, but it should be clearly defined. So, and the eligibility criteria. In common cold, for example, you may not include the neonates. Only 1 month or 2 months age, they are usually not coming out of the house, etc. So you should define that. And usually when it is a hospital-based or OPD-based study, try to expand we'll see that out of these 62 topics which are selected, which are the topics which we can take out for the multicentric study. We are 62 participants, but the centers may be from one center 7%, another center 2 or 3%. So we may have around 35 or 40 centers. And if 10 people are likely to join for a particular study, or even if we have 3 or 4 multicentric studies, that will be much better. And I hope that on Wednesday, you should be very clear that your single study, hypothetically at least, should do everything: cross-section study, cohort study, and also the cross-sectional, case control, and cohort. All the 3 should be there. And if possible, we'll try to randomize also. Let's see. And that the same database will try to interpret in a different way. And the controls, it written that must be free from disease and the studies. That is true. But then similar disease or other kind of disease could also be there. Suppose if it is a common cold, then another person having, let's say, fever, or let's say malaria. So common cold without fever, common cold with fever, or malaria without common cold, there can be so many things. And if you can take a multiple controls, you will have much better inferences. Only thing that when you want to take a more varieties in your study, sample size also you need to increase. So you think of nowadays, because of a telephone and Google Form, so many things, the survey techniques also are there. So it becomes easier for you to do the study. And it is written that ideally 1:1, but what happens that sometimes the cases are usually we can find out 10, 15 easily, but the control also is easy. But difficult cases where you find out much less, at that time you can increase your control. The matching naturally you will do for age-wise, sex-wise, gender, the socioeconomic condition-wise, or let's say whether the background of the person, the psychological makeup, that also sometimes you need to make up. Then why the word is odds ratio is used over here and not the relative risk or the attributable risk? Simply because here we do not have a denominator, and without denominator we cannot have a relative risk. That's why we directly say that odds of exposure among cases, odds of exposure among controls. And when you compare, when we say that odds ratio, if it is, let's say 3, 4, 5 like that, it is not exactly that much risk, but we usually say that it is more association is there between exposure and outcome. Now, at least the people of the community medicine should also remember that there is a, based on odd ratio also we can find out whether this odd ratio is significant or not. And that interpretation we can find out from the odds ratio from 95% range, whether it is beyond that or not. So in a case control study, also we can have a significance, the association or not. Now we'll go for the next file, cohort study. In cohort study, we are starting with exposure. For example, people who are eating vegetarian food, people who are eating non-vegetarian food. The rest of the thing are almost equal. Only the diet is changed. Or you may take people are consuming a particular medicine, other people are not taking a particular medicine. Or let's say on vitamin C and the dietary vitamin C and the tablet form vitamin C. This kind of comparison can be taken, and two groups, we continuously follow them up for the result, that what is the outcome that we can compare. So cohort means group. We are taking one group, two group, three groups, four group. If you take only one group, you will not be having a control, then it is difficult to study. So you need to have exposed to one, the exposed, non-exposed, or you can have 4 or 5 things also together. Let's say one group was given only medicine, other group was given dietary advice, third group given dietary advice plus medicine, fourth group was giving dietary advice plus medicine plus physiotherapy, like this. So you can have multiple groups, but you have in hand defined number of people, and then you follow them up prospectively. So it's a cohort study. So this is a prospective cohort study. But then you want to do it fast. In that case, you define your cohort way back, let's say 2 years back. How many people were studying in this school? And those children, you should have clear-cut idea. And how many of them you will be able to stress? If you can't trace some of the children, then they will be taken out of the study, and there could be bias because of that we need to write in the study limitation. So 2 years back, let's say there are 4,000 children were there, and in last 2 years, what happened to them? Few children were studying in English medium, another children were studying in a Gujarati medium. You are following them up, right? Retrospectively, what was the results? And then again, next 2 years in their college performance, that also you can do. So if you do the retrospective cohort study, or you can do the prospective cohort study, or you can combine the two things together, retrospective cum prospective study. And I at least expect all 23 or maybe 22, 20 students who are joining to have at least one kind of example where you are doing the study. The rest of the 40 people, I'm not going to certify unless they fulfill certain criteria. One criteria is a project work. Whether it's if it's a real project work, that will be much better. At least hypothetical, you need to write down. And the group discussion will tell us whether they are proper or not. Because 62% in a single hour, it will difficult to evaluate. So I will be watching from tomorrow onwards the groups, whether you are fulfilling certain exercise or not. So in cohort study, let's say risk factor and no risk factor, we have two things together, right? Now, another thing which you should remember that sometimes we take a large amount of the people, 30 villages as a control group and 30 villages as the study group. In study group in 30 villages, you are doing some kind of the experiment, for example. So if you are not doing the randomization, right, you are just keeping two groups like that, and you are doing some intervention trial, but then in that there is no randomization. 30 groups people, you are giving iron folic, another 30 people, you are just giving leaf vegetables, and then you are following that up. This is a simple cohort study again, although it's an interventional study. So while comparing these two groups, now you have a population in hand. That means you will be able to find out this many people were exposed or suffered or given some medicine, and you can expect certain kind of outcome. And in another group, there was no intervention or no exposure, etc., and you have outcome. So this, when you are comparing, you have a population in hand. So here you can use the relative risk. But because it is a word case, you are using the risk. In terms of when you are having outcome as some positive outcome, that improvement. So at that time, you should not use the word relative risk of improvement. At that time, you should use the word chances of improvement rather than relative risk. As a teacher, we should remember this. For UG student, it's okay if we continue to use the word relative risk. In that case, we'll be using probability of improvement. That also we can use the word. Now, we are taking one example. So the steps are already, we need not directly go for that. Directly go for the calculation. This is what we want to have, right? Here, because we have incidence rate among the exposed and incidence rate among non-exposed. This is how, because of this, we are able to find out the relative risk. In that case, when we are doing the case control study, we don't have a total population in hand, and that's why we were not able to use relative risk and we were using odds ratio. And here we just say exposed among and the non-exposed, right? So this will give us that how many times there is a improvement. And in AP Info, you see this relative risk, and you'll also find out the p-value. Based on that, you will say that whether the association is by chance or association because of some reason. And this attributable risk is very simple, that if there was no exposure, what will happen? What is the contribution? Instead of you use the word contribution, it will be very easy. What is the contribution of a particular exposed factor that this disease has occurred? Or if you remove this, how much you can reduce it? In case if you are doing some intervention, how much improvement was because of your intervention? This also you can use. So in terms of when we are using the cross-section study at a stage, right now what is the outcome, what is the exposure. At that time, we are not looking at the linear relationship. We just at that time start to find out standard of difference to proportion, whether they are associated or not. That is only what we are doing. Now, about case control and cohort study and prospective cohort study, at least 3 or 4 people write down in the chat box what kind of study you can really do it. Even 2% write, that's okay. And then we'll switch over to the sample size and sampling techniques. Anyone who can write out some immediately? Cohort study example. For example, right now we have 2 cohorts for see out of 62 people, 62 participants. We have 2 groups, regular and irregular. Of course, we'll define that and regular. So, and then if you follow them up, that what is the outcome, whether they could accomplish certain exercise or not. So that will be, we follow them up, whether the regular and irregular exposure is a study, and then we find out whether the performance is better or not. That's the cohort study. So anyone who can, who are thinking to have some kind of in your college, for example, students who failed and students who passed. Failure is a case and passing is the no case, right? And then whether they are staying in hostel or staying at a home, whether they're reading properly or not reading properly. This kind of thing, you can say case control study. Another thing, now we will go for the calculation of the sample size. And because this you are supposed to do it for your study. In that sample size, you can have 1, 2. This is, let me share on the Zoom, share the screen. I hope you are now able to see. So whenever you install the AP info, it will ask where you want to install. And that is very important for the path. Otherwise, it will search, go on searching. That's why it is important. In this, we have one classic analysis. Most of you have, by now you know it, but there's something like create forms. You can use either a Google form, or even you can go do the create forms this also. Or you can also directly use the Excel. And in this, AP Info uses the word project. This AP Info is itself is a very big thing, but this is just an example. Just a minute. Now it is better to keep this both files on the C drive to have minimum problems. Now we are creating a new project, right? And this is about community health. In that, we are doing many projects. So we are doing on the nutrition. Now, don't worry about the whole things. You can, there are so many things. We are not covering whole AP info, but just simple things. In nutrition project, in page 1, you are putting a label. For example, from here, and your label is just nutrition survey for children under 5. It will take a field name. You say, okay. So this is the title. Now, there are various dates and so many. These are the variables, different kind of variables. We'll just take one or two. Name of child. This field name you can change if you want. And if you want to require, if it is a must, write down required and say okay. Right? Then you can take a number. For example, age in months. Here also you can say required. You can also have a validation. It takes around whole day to teach this, but then right now we are taking very simple. And here, then another thing we take, for example, text, gender. Whole question you can write like this. What is the gender of child, like this. It will take field name automatically, but this you can change yourself also. It could be like this. And if you say required, keep it like this, and then okay. So you have name of child, age in months, then what is gender, and malnutrition you can have weight, etc. For that, you again take a number. You can say WIGT. I am not taking too much time. And you can say range, for example. Range should not be less than 1 kg. Weight in kg, let's say is a weight in kg. Then here, maximum and less than 5 years, so you can write 50 kg. So, and it is a must, you should write required, otherwise it's okay. Okay. Then comes another, we take two countries variable, gender of child and sickness in last 1 month or no. So let's say yes and no. Sickness in last 1 month, right? And so let's see. So this is yes or no will be there. And then there you can take a legal values also if you want to give so many values, say out of 4 values you should be taking. So I'm keeping it over here. Legal values, let's say a type of family. And then it is not required, but then data source, if you have a ready data source, for example, 40 disease or 40 symptoms, you can directly call over here. But right now you don't have it. So you can prepare your own data source, create a new. So you will take, for example, the joint family. Then you will take the 3-generation family. Then you take the nuclear family, and then you can write. Now, if you want a sorting, then it will be according to ABCD. But if you don't want sorting, you write don't sort over here. Say okay. And then also okay over here. So now your format is ready. You don't need any programmer. Now you can save it, and just save file. Here because of this. You can directly go to the enter data. Yes. Yes. So in 5-7 minutes, we are able to make a format, and then we'll let us start with this. Ramesh, age is less than 5. You can put a range here also. Let's say 14 months. And then what is the gender of child? Let's say male. Weight into kg or 20 kg. 14 months, we don't put this much. Let's put 12 kg. Sickness, yes or no? Let's say no. And type of family is a joint family. So, and then next data you can say from here, new record. You add another record. Fish, 18 months, 10 months, child female, weight in kg, 10 months, so you can 8 kg, sickness, no, type of family, nuclear family. This is how we can use the data. So save. And you can see the two data over here. And then we can come out of that. Now we go to the classic. Too much windows open. So we have done now format was prepared. We enter the data. Now we are going for the analysis. Or read file where the data source was. Projects in that CHP project. And in that we have, in one project, you can have many database. That is possible. Is a nutrition, or the same database can have the other kind of study, etc. Okay. Here you have two records, and then you can go for frequencies. Then you can have a table commands, right? Exposure variable, for example, type of family, and then illness. Sickness is there, sickness in last 1 month. This is how you have, because there is no sickness, both the thing. So table we could not call out, right? So this is how you can, all the three things are over. And this you should practice, create the forms, enter the data, and do the analysis. Now, our main objective for you, for in your study, is to find out a sample size. So this will give you the sample size. Which kind of if you're a core study or cost success study, according to it will give you the things. If you are having 2x2 tables, it will calculate for you the chi-square test. So now, when you have a rare event, Poisson distribution, for example, out of 1,000 people, you will have hardly one person suffering from hemophilia. At that time, if you want to go and study that, though if you want to take a simple size, at that time you need to use the Poisson distribution. Right now, let's say we are going for cross-section study. So in this case, you need to give power of study. Now, when I was telling about the beta error, right? At that time, I meant 1 minus beta, there's a power of the study. So usually, let's say we take is 80%, ratios unexposed and exposed. That you can put it over here. Then outcome in unexposed group. Let's say it is a 10%, and exposed group here. This I need to go for. Here automatically it will change if I increase the power 19. And if this is outcome keep 2%. 15%, 15%. And I take 70% to 4, 5%. Go for 95% confidence limit. 50%. You go on changing this, and the sample size will change over here. So this is how you can play with the what you want to keep it, and it will automatically change over here. Suppose if I do it over here, you can see the sample size increase it 1573. If I decrease the power, it will reduce sample size. So it depends how much accuracy you want with your study. Then we can, similarly, you can use other population survey or the match pair case control study, etc., and try it out that if you keep a different thing, what will happen? If your population size, you want to keep, let's say 10,000. And your expected frequency is, let's say, you have around 10% people you will find. And margin of error, that when you get a percentage, suppose you get a 30% result. So you want to have 35 to 40, or you want to have a 20 to 40 something. How much on both the margin you want to keep it? Let's say 5% I'm keeping it. Design effect is very important. When you are taking it directly from a simple random sample, there is only one design effect. But when you stratify the data, let's say the whole Ahmedabad is there, and you are not taking directly from Ahmedabad, you are taking into things, you're stratifying into the wards. And then from wards, you are taking this for the sample. At that time, you have divided that, so the design effect will be 2. If you further stratify that the different kind of caste within the ward, the design effect will be the 3. So right now, if I keep this, then you can see the sample size. Now, if I reduce the margin of error to 2, look at the sample size, 2,541, which is required. If you see the 95% is 796. So similarly, you try with this sample size, and you will be able to know how it is used. I hope that this answer your some of the points, and I will stop sharing over here. And I assign the task that you should be ready with project proposal. If not everything, at least you should make a title. You define your population from which you want to do it. Define the sample size, how much you would like to take, type of study. Then you design the format. If you're not comfortable with AP Info, you can go for the Excel. Design the format. But if I tell you that if you do with AP Info, the advantage will be the less error, because it will give you a lot of validations will be there. So if it is possible for you, that will be better. Design the format and maybe collect data. If some of you are comfortable with AP Collect is a app by which also you can collect the data and then analyze by the AP Info. So it is up to you which you would like to say, collect the data. At least I would say that if you collect around 50 data, it will not be that difficult. And then you should be using the read command. Read command. Read command. Then Dr. Rahul Verma is not in this meeting. Who can see your message? Okay. I'm after the read command. Everyone. Oh, I'm sorry. I wanted to. So project proposal. Title should be there. Title. And let me cut it short. You should also have a population sample size type of study, design the format, collect 50 data, and try to use at least minimum this commands, tables, or read, then means, frequency. These 4 commands you should be using. And if possible, for advanced user, you should try to use logistic regression. Right? And the select command is very simple. And so select command also you can use it, select and deselect. But before you start your the analysis, I request that you should take a printout of the foliar frequencies, and then it will be much better to do the analysis. So now the forum is open for a question, and tomorrow onwards, the group discussion will be started, and the small test may be taken so that whether you have understood or not, that we can find out. Any question so far? Dr. Seema, Dr. Nilab, Dr. Madhukar, Antil Kohil, Sunil Gargi, Randhir Kumar. So it's too easy, I think. So there is no question. And I hope everybody will be able to do it. So in chat box also there's no question. Dr. Anuj, can you introduce yourself?
Hello.
Can you introduce yourself?
Yes, sir. Myself, dentist working in a government setup, Mansa Civil Hospital, District Gandhinagar.
So you have thought of any topic, dental caries or dental hygiene, or the Colgate or some kind of the toothpaste versus the drumstick or the Datun, for example, neem stick. So some kind of
Actually, I was thinking about where I am practicing right now in a government setup. I come across a lot of patients who are using that snuff or chikni for cleaning that tooth.
Yeah.
So I was thinking something of that topic because I am regularly getting patients who are using that, and then they are coming for the staining of teeth and pre-malignant lesions.
So see, Anuj, we have 5 more sessions to go, but
Yes.
before that, this interim period is equally important. I don't claim this within 10 hours you will be able to know everything, but
Yes.
the material which I am sharing with you, the exercise which I am giving you, or the APA info, etc. If you use it simultaneously, it will be very interesting. And the end will not be at the end of the 1 month. Then maybe a once a week or once a month we continue to work together, so that as an outcome, I wish that whole country, that all the dental colleges of our country, at least 10 or 30 or 40 colleges work together on a same format. And that's why we have started a virtual medical college. I am not using the word dental college right now, but it could be like that also, so that the right kind of people come together, do the multicentric research study in a better way, and then share the information with the people. That's the objective. So I hope that
Yes, sir.
this was something, right?
Yes.
Anyone else want to share anything? Dr. Tushar, I'm just randomly picking up. Can you have some light on your study or on your experience, or what do you do like that? Dr. Tushar Kalra.
Good evening, sir.
Good evening.
Sir, I am doing a research and observational study on one of your instruments that you have made, that is MTech emitter.
Vitamin A deficiency instrument. Okay, MTech emitter. Right.
Vitamin A deficiency. Yeah, I am doing.
Yeah, you're already doing you have already done a wonderful work in terms of the pre and post, etc. But then I want you to analyze the same data in AP Info. I have got the data, but then you have tried also. But if you use that kind of this app test and find out the probability, etc. On a different things, because the sample size was very small, only 80, right? So if we go for the multi-sensor, it's the same instrument used by a 4 or 5 setup, that will be still better. So it is already we have sent for patent vitamin A deficiency detection without taking blood, for the informing to the rest of the people. So would you be able to analyze with the AP Info?
I'll try, sir. I am learning still.
Yeah.
I'll try my best.
So if you fail, then on Wednesday, what I want that whatever difficulties you have, right? That first I will solve. And if you all agree that I may start 15 minutes before the time, maybe 8:40, 7:45 for those who have trouble in AP Info. If you clear that, then maybe 8 to 9 will be working on the rest of the critics on the various the uh, type of studies, because each group will have a critics on their colleagues, that what are the fallacies and how they can be corrected. So that kind of 12 groups presentation, each group will have one presenter over here. They will present what kind of study they have taken and what were the problems and how they could solve. So each group will take around, be given around 2 to 3 minutes to present their group, whether all the topics will not be disclosed, but whatever they found in the discussion, the pros and cons or some limitations, etc. So the Wednesday will be the practical discussion on the study done by or whatever you are planning. That will be the Wednesday, and then after that, the seventh session will be on non-parametric study, which I hope that all of you will attend, because the Mann-Whitney test and the Kruskal-Wallis test, all those are only simple tests. But then if you understand that where to use it, how to use it, that will be much better. So thank you all. I end over here.